Hello everyone, welcome to my channel. So if you've seen Kung Fu Panda, there is a specific scene where Shifu tells to Po that now there is a level 0. So I have take inspiration from that and I wanted to create something similar to coding. So let's say you just came into coding or you have tried to come but you got zero clue on what is what. So I want to start from the core basics of what are the simple things you have to know before you move on to coding. Obviously, the coding entire structure is based on using the computer. So if you don't know how a computer works, you have no clue on what to code or why are you coding. So first, let's look at what does a computer does. A computer is simply electricity. Well, how is that? Well, a computer consists of something called as a CPU. Inside this CPU, which is basically the brains of the computer. Now, what does this CPU do? This CPU has something called a transistor. There are millions and billions in the modern ones. And what this transistor? Well, simple. What the transistor does is it's simply a switch. When it's on, it allows electricity to pass through, and when it's off, it won't pass. Simple as that, right? Well, how can we go from a switch to these brains and computers that do all this stuff, even AI now? Well, it's simple. In this CPU, instead of just using transistors, these are laid in a special manner called as gates. They're mainly three gates: and, or, and not. Okay, so the core principle is really simple. In AND gates, you want both the inputs to be true, only then the result is true, or else in remaining cases it is false. OR is like the opposite. Even if one is true, it's always true. Only in the case both the inputs are false, it is false. NOT is simply an inverse. If it's on, it's off. If it's off, it's on. So simple as that. Okay, so now we figured out how the CPU works, right? So to put it simply, these gates, which is we use these AND gates, NOT gates, and create more complicated variants of them, and that's how the CPU works. That's the brain of the computer. Okay, now we got the CPU. How are we going to control the CPU? Well, simple. We use something called as machine language, assembly, and different CPUs have different machine languages. Even right now, if you go to the market, in the CPU market, we have a bunch of CPUs. For example, in the mobile market, we have Qualcomm and MediaTek. For Apples, we have the A series, and for laptops and computers, we have the Intel AMD. Now we also have the Snapdragon X Elite, I think, and also the M series for Apple. So we have these many CPUs, and every CPU follows their own machine language code. And after few CPUs came to the market, it quickly became many more CPUs, and it became hard to learn different machine languages for many things when you just want to build the same app in for everything. So to solve that problem, we have the first main coding language called as C. So C is simply an overcoming the limitation of these different machine languages, where we can use C to write code to any CPU. And that is the advantage of writing in C. You don't have to write multiple times in different machine low level languages. So now we get to a new topic known as the level of languages. There is low level languages, there are high level languages. What's the difference? Well, it's actually pretty simple. We humans normally we speak in our own language, let's say English. The machine, however, it speaks in, as I said before, electricity, which is basically binary. Off is 0, on is 1, which is binary. So when the language that we use to tell computer what it does is closer to binary, we call it low level language. But when it's closer to our English, it's called high level languages. So for example, if you take Python, in Python we don't use many fancy symbols. It's always just mostly words like in, etc., right? Because of that, Python is closer to English and we call it a very high level languages. But if we go to C, there are a lot of special operators like pointers, the dot operator, and many more such, or even the hyphen and arrow. which we can use for allocation memories and etc. And because of those many low level operator things and low level control of the system, we call it a low level languages. To be correct, C has both low and high level now. When it was first released, it is actually high level languages, and now Java, Python and other such modern languages all basically come under high level languages. Okay, so now we have different languages, and we know we can use this language to basically control our system hardware, from which we can basically do anything. So now what is coding and why do we have different languages, right? So coding is actually a very simple concept. To put it simply, I will write a bunch of text, okay, any characters, something which every language has its own rules. So using those text, we'll write something, and using that we can accomplish something, anything on the computer. It ranges from simply like writing some notepad or creating like a notepad app to as complex as creating an entire operating system or even a large language model like ChatGPT, DeepSeek, etc. Gemini, all the present AI. So what's the purpose of different languages? Well, simple. Different tools are better at different things. I like to see programming languages as almost vehicles. For example, if you want to go to a different place, depending on distance, you're more likely to choose a vehicle, right? So for example, you want to travel over the seas, the flight is the best option. If you want something like a long night journey that's comfortable, you would prefer a train because it has washrooms. In buses and cars, it's not that easily available. For example, it's a 2 hour long journey, then car is a more preferable. You can happily sit in AC and enjoy the ride. And if it's only like 10, 20, 30 minutes quick ride, then bike is probably the best option. If it's raining, then car would be another best option. If you want to travel on budget, then you want to use government provided traveling facilities and such. Similarly, in coding languages, different languages have different advantages. For example, Python, it's more suited for AML task, data scientist, where you need no form of limitation when you want to do number calculation. For example, if you take Java is something where you want it to be OS independent. For example, you write a code, you want it to work in Linux, Mac, Windows, Android, anywhere. That's the best thing about Java. It's an OS independent software because of the JDK. For example, let's take C. C, although it is OS dependent, it offers you a very low level control, and if you properly write any code in C, it will absolutely be the fastest code possible. And that is the different advantages of coding languages. Now we have talked about these coding languages. Now let's get to the beginning of these coding languages. So how do we know exactly what is code? And obviously we previously have told that we wrote some text, right? In this text, it contains both the rules and regulations let's say I created for it to follow, and there are few commands that I said I want it to follow. How can it say the difference between, let's say, these rules and regulations while also being able to follow what I want it to do? For example, I want to tell it sit means it has to sit. Okay, how will the computer know when I'm explaining what is sit and when I'm telling it to do what is sit? We humans, let's say we want to play sit stand game. When I say sit, you want to sit. When I say stand, you want to stand. Okay, humans, we can easily understand this, but computers, we have to tell them each and everything. Only then they can do it. Everything is like extremely manual. So what we do is, inside every programming language there is something called a main function. Okay, this main function is what tells the computer that you are following these orders. Okay, whatever you write in main function, it will be executed 100%. What happens if you write outside of the main function? The computer will read it, it will analyze it, it will check if it's right or wrong, but it won't execute it. So for example, you want to tell a computer to sit and stand once. Then inside the main function, you write once sit and you write once stand. But if you want to tell to a computer what should it do when I say sit and what should it do when I say stand, you want to write it outside of the main function. Now the computer knows what to do when it means sit, what to know when it's stand, but it won't do it because we haven't wrote anything in the main function. It is a very simple concept, but I would say if you start from this idea of clarity, it's better to move on to the coding next. Next, we have something called as a syntax. Obviously, main function, the way we write this main function won't be same for the every coding language. Different coding language follow different rules, which is nothing but called as syntax. Similarly, how we have grammar for different languages, English, Hindi, Telugu, French, German, everything follows a slightly bit different grammar. Okay, for example, in few languages the predicate come first, in few languages the subject come first, and etc.